Yes, it is okay. Part one is next. Number one from your review. Pretty fun. The first thing we do is pack the bottom, and then figure out what type of case. Case one, there's I think we have 5. Right? 2x minus 5. This will be x minus 6, x plus 1.
Okay. Then we said, okay, since these are distinct factors, then they will factor like this. So that was case one. You guys remember this, all this from the beginning of the semester? So just showing me that, I'll give you half the credit for that problem. Just getting to that point, I'll be happy giving you a lot of the points. The rest of the points will be just solving for A and B, right? So what we said to do is you start here. So multiply both sides. By the LCD. And once we do that, it's going to cancel everything over here. So I'm going to go ahead and show it since it's review. So there's LCD on each single term. The left side will only be left with the numerator. Right hand side will be left with the factor that's different. So x plus 1a plus oops, I made a mistake. This should be plus 1 down here. Plus x minus 6 times b. So at that point, so I've been showing you the system way, right? We made a matrix, we solved for AB. So in the homework, I think, I don't know if they do anymore, but I'm gonna show you the other method. Did I show you the Heaviside method? Or no? Or did I only show you the matrix style? Okay, so let me show you the other one. So the other method is cool, but only if it's a simple type like this one. If you have like just an A and a B and maybe a C, you're good. But when you have A, B, C, D, don't use this. Okay. So all you got to do is let X equal -1 so I can cancel this guy. See what I'm saying? So plug in -1 everywhere. So you get -2 minus 5 equal to 0 minus 7b, right? So now notice what happens, right? You can just divide by -7 and you have b automatically. So we can avoid the systems and all that stuff. So we get -7 right here equal to -7b. Divide both sides by -7 and you have solved for b. So that's called the Heaviside method. Some guy's last name, I think, I forget. So you can do the same thing for 6. Let X be 6, cancel this one, and you can find the A. Does that make sense, the approach? Okay, if you want to do it the other way always works. The first way I showed you. You can always make a system and use a matrix. But if you want to do it this way, that's fine, but make sure you know when to use it. So if I let X equal 6, that's going to cancel this guy, right? Here we go. That's 12 minus 5. So what is A? A is going to be 1, right? So this implies that A is 1. So the final answer will be, it's because I ran out of space. You cool if I skip this step here? So X minus 5 over X minus 6 times X plus 1 is equal to 1 over X minus 6 plus 1 over X plus 1. Close the door. Okay. Any questions on the beginning, the setup, or the algebra? So this is question, oops, super remote. I think it's the first problem in your review. Okay. The exam will be very similar. So if you do the review and you understand it, it shouldn't be too bad. But on the exam, I want to see all your steps. I don't care what answer you choose. Even if you choose a wrong answer, but your work's good, I'm happy. Right. We'll probably take it in class, but it's gonna be through that respondents thing. But I'll let you know. Maybe I'll let you take
Do we
it.
have to use that like equation keyboard to show our work, or we're gonna turn it like?
No, you're gonna scan your work.
Oh, okay.
Yeah, whatever app you want to use. I don't know, Apple can use the notes. You can just take pictures real quick and put them in the notes. If you have a Android, they have a built-in scanner. I forgot what it's called though. But the app, yeah, CampScanner works too. Whatever. What do you want to do, man? You guys excited to be back on campus? Yeah.
In person in college, and I only have like 3 more classes to take after.
That's funny.
I don't even know where to park. I don't even know how to.
Yeah, one of my buddies just got hired, and he hasn't taught in person at all. So it's weird how things are, I guess. Anyway, you guys cool on this method? If oh, I'm sorry. Yeah, no rush. You can write it down. If you like that method, feel free to use it. But if you, like I said, if you have CD, like once you have a C, it's risky. It really depends. I would use it if you have A and B for sure. I would not use it for when I start seeing a C or D. I start doing the system matrix. Also, you guys are able to check out a calculator if you get here earlier. I don't think they're open anymore. They have those 83s right there, 84s. Everyone can check one out. You can use it if you want. They have a matrix built in, and
Can you go over how to do it on the calculator? That way if I do it on the.
yeah. Well, let's say we make it up. So the step that I'm gonna redo. Let's say you multiplied the A through and the B through, right? I guess since we're recording, I should do it over here. Let's say you had this side here. We have AX plus A plus BX minus 6B, right? Gather the X's together. And the constants together. Then we create an equation equal to, I forgot I need to have 2x minus 5 over here. So A plus B is equal to the X constant. A minus 6B is equal to the negative 5 constant. You got the top part? The first line? So let's say you did it this method instead. What you would do on 84, 83. I don't know what I'm hitting every time. It's weird. Maybe there's a lot of wire. I don't know. All right, so you agree that the matrix will be this, right? 1, 1, 2, 1, negative 6, negative 5. So hit second, and then go to the X inverse button right here. That takes you to the matrix menu. Once you're in there, you're going to edit the first one. So go to edit. And then we got to decide, all right, what is the dimensions? Well, we have 2 rows, 3 columns. It's always row by column. I always think of RC Cola to remember. Row first, column second. So 1, 1, 2, just press enter when you type it in. Make sure you use a -6 symbol, not the minus symbol. They're different. You'll get an error if you use minus. You gotta put the negative down here. Once you've put it in, just quit. Go back to the matrix menu. See how now it's saved there, 2 by 3. Go to math, this math category is all the functions and operations for matrices. Go all the way to the bottom. And you're gonna find RREF. So that's row reduced echelon form, which basically solves it for you. So now it's waiting for a matrix. So press enter on RREF. Back over there. Choose the A. And that's it. So A is 1, B is 1. Right, that's how you read the matrix. All right. Anyway. This reduces to 1, 0, 0, 1. There. Which gives me this piece and this piece. Any questions on this problem? Okay, you guys good? Let's do another one. Let's do a harder one. This time it is going to have A, B, C. And it looks like, yeah, this method will not be good. This is number 3 on your review. So I'm skipping number 2. And the instructions are just decomposed into partial fractions. This is the first section we did together. You see how this is a difference of cubes. Do you remember how that factors? This is cube minus a cube, right? That's x minus 1. X squared plus x plus 1. So we use the difference of cubes. Is that all right? Is that clear or no? I'll write the formula up here. Something cubed minus something else cubed is equal to that something minus the other one times a squared plus ab plus b squared. Okay. So now we do the setup for partial fractions. So the first one is a linear distinct factor, right? But what are you gonna put on top of this one? What goes on top? Yeah, it's gonna have B and C, right? It's the whenever you have something that's not linear. Remember, it was you're close. Bx plus c. So that's the setup. So multiply both sides by this LCD here. I'm not going to write it on the left side because it's just not enough space. But we know that this is going to cancel the whole thing, right? So multiply these two pieces on each one. So x minus 1 times x squared plus x plus 1 times a over x minus 1 plus x minus 1 times x squared plus x times the other one. So x minus 1 is gone. This garbage is gone. So we're left with 13x plus 2 equal to this plus x minus 1 times that bx plus c. Okay. All right. So we're going to distribute, collect all the quadratic, linear, and constant terms. So ax squared, ax, and a, once you distribute, this will have to be a FOIL, so you have bx squared minus bx plus cx minus c. Second. All right. Collect the ones that are the same and then start equating the coefficients. This is not a good one for heaviside. Okay. So I'll show an extra step. It's not necessary, but factor the x squared, factor the x, and create your system. There is no quadratic. There is a x term. There is a constant. So that will become 1, 1, 1 for all the a's in each equation. 1, -1, and 0 for equation 1, 2, and 3. There's no b here, so 0. There's no c. This has a 1 and -1. Augmented with this. Okay. So solve it. See. Put it right here, I guess. 3 rows by 4 columns. So 1, 1, 0, 0, 1, -1, 1, 13, 1, 0, -1, 2. So back to the matrix menu, go to math, go to RREF, go back to the menu again. Just choose the A. So this will be solved into 1, 0, 0, 5, 0, 1, 0, -5, 0, 0, 1, 3. So our answer will be, so 13x plus 2 over this weirdness is equal to A, which is 5. So 5 over x minus 1 plus -5x plus 3. This will be my answer. All right, 1 second. Okay, so here's a review test right here. This is what we are working on right now. So we did this first, number 1. Skip 2, and we just did 3. So it looks like this is D, right? You guys remember how to do the degrees in minutes and seconds?
You do this, number 6.
That's cool on this page. You're not good, right? Yeah, no rush, man. Just tell me. No, sometimes they go a little fast.
So did you say the exam will be in person then, like next week?
I was thinking either doing a respondus, we'll record you, and we can just either use that time to go over something else, or maybe just take the day off or something. We'll see. I'll let you know soon. Just make sure your response stuff is working. So you're good? All right, number 6 from the review. You can see it on the video. It'll be this guy. So convert down in degrees to radians. So 105 degrees. So to go to radians, you have to multiply by the factor pi over 180. Let me switch back. So if you're unsure, like it's 180 on top or is it on the bottom, just remember if you want to cancel degrees, then you gotta have degrees on the bottom. If I want to cancel pi, then pi should be on the bottom. So these will cancel, giving me 105 pi over 180. At this point, it is technically in radians, but we got to reduce the fraction. So how many fives go into 105? 21, right? Is that right? 5 is going to 180.
$16, $18.
180 divided by 5 is 36. Appreciate the guess though. Trying to guess myself. All right, so 5 goes into both this many times. Does it go reduce further? Or is it good?
Seven.
7 over.
Yeah, looks like 3 works, right? So 7 pi 12ths is the radian representation of 105 degrees. That's as far as it's gonna go.
Can we do 5?
Yeah, you can do 5. 1 sec. Convert the angle to a decimal in degrees. Let's see about formulas. I forget. 1 second. I think it was 7 1. We're going from degrees, minutes, seconds to, okay. So we just need the formula for minute and second. There it is. All right. So 30, 15, sorry, looking at the wrong one. 15 degrees, 59 minutes, 15 seconds. So we're going to use is 1 minute is equal to 1/160 degrees. 1 second is equal to 1/3600 degrees. You have to remember that this is just addition. So 15 degrees plus 59 minutes plus 15 seconds is the same thing. The 15 degrees is already in degrees, so you leave it alone. Let me switch back. Sorry. So we just gotta convert this piece here. So this is the same as 59 times 1 minute plus 15 times 1 second. So plug in the formula. Be 59 times 1/60 degrees plus 15 times 1/3600 degrees. At this point, we just need our calculator. It's not gonna be 15 plus 59 divided by 60 plus 15 divided by 3600. 15.9875. Okay. 15. I don't know what the question asked for. 2 decimal places. So we would choose D, right? 99. So yeah. Any question on this one? Oh, in the calculator, you just put 59 divided by 60 plus 15 divided by 3600. That's it. Add those two to 15 degrees.
Just because you kind of made quick work of number 6, I noticed that the inverse is 7. 6 was 7, like going the opposite direction. Are you just multiplying it by 180 degrees to get from the opposite direction?
Yeah, you just flip it to go from radians back to degrees. They're saying. Yeah. So you would if you wanted to change this back to degrees, you'd multiply this by 180 over pi. And that would cancel the pi's and get you back to this. That's what I'm saying. So depending which direction you're going, you flip it the right direction. So if I'm going to radians, then I want degrees on the bottom to cancel. If I'm going to degrees, I want to cancel the pi's. So I would have the pi on the bottom. But it's the same thing. You guys remember converting like inches to feet and all that? They would multiply by those fractions. Remember doing that? It's the same deal. Like, yeah, like it's just like we're going from like moles to milliliters to whatever deciliters. It's the same thing except it's just one step. This is a fact of a form of one, like you'd multiply it.
Add 12 inches divided by 1 foot. So the seat cancel. Giving us 24 inches.
So same deal, it's just we're doing radians and whatnot. Okay. Any other questions on number 6? All right, you guys good then? Let's look at the exam again. 6, 7. So this is degrees to radians, radians to degrees. You want to do that one? Or- Yeah. All right. Got plenty of time.
Also, just because I'm curious, our classes end at the same time, like every time. It shows on the syllabus 8:50. Is that correct?
Wait, no.
Yeah, I was really confused. That's all that.
I had
I thought it
first
was-
750 and then
Yeah, it's 7:50 technically.
Okay, I just was thinking that's a lot.
Yeah, that's too much. Put myself to sleep at that point. That's weird. So it changed on the syllabus that we said?
Yeah, like before class started, that's what it said to like it was born set to 8:50, and then I looked at it again because I have like all my sticky notes
Yeah.
on my computer, and it said 7:50. So yeah,
Strange. Oh, well, yeah. Won't be here that late. I will be, but not you. I have a class at 9 p.m.
Is it this?
Hmm?
Is it this as well?
It's Cal 1, Calculus 1. Same room though. I wish it was right after because now I gotta stay later. It's like got an hour in between. Anyway, how it is, I guess. So multiply this by the conversion factor. 180 degrees over pi. So these pi's will cancel, leaving me with 10 times 180 degrees over 7. Does 7 go into 180? Does it go into 1800?
so if we're returning in our work like for this problem, would we be able to just put like skip the steps if we know it's just gonna be 1800 divided by 7? Or do you want to see the whole 10 pi over 7 and see the pi's cancel out?
This step is good. To show this first, no, sorry. Yeah, so this step right here, and then you can skip to some part, especially this question because it says decimal. Like you can punch this into your calculator actually. They tell us to round to something. what was it? Well, they don't actually tell us. They should have told us, but it's two decimal points.
Basically, as long as you see us cancel out the pi or cancel out the degrees, then we'll be fine.
That'll be fine. But if it's an exact answer, put an exact answer. If it's rounded, then use rounded. Any question on 7? Is that all right? So this is just the the conversion factor. Like 12 inches in a foot, there's 180 degrees in pi radians. So you just always multiply by this if you're going from radians to degrees. It's always this. If you are going the other direction, if you have degrees, then you multiply by this one to get to radians. It's always the same. You got it. Okay. Number 8, we do one of these on the notes, but just you want to do one of these? Does it make sense? Yeah. Okay. What is a linear speed? Do you remember what linear speed is? So write down all this information. Objects traveling around a circle with a radius 10 centimeters. So R is 10 centimeters. If in 20 seconds, okay, time is 10 seconds, or 20 seconds. A central angle of 1/3 radian is swept out. Okay, so my angle theta is 1/3 radian. What is the linear speed? Find my formula. maybe it's the next. You guys remember what section linear speed was? I forget. There it is. Sorry about that. So linear speed, v is equal to s over t. So we got to find s. Do you remember what s was? It was the length of the arc, which is found by doing r times theta. Which in this case will be 10 centimeters times 1/3, which is 10/3 centimeters. So the speed will be 10/3 centimeters over 20 seconds. Now let's see if they have it in decimal or fractions. Looks like decimal. So this will be 10/3 times 1/20 seconds, centimeters. So that'll be 1/6 centimeters per second. Yeah.
What's the centimeter number before? Oh,
Here?
yeah.
So it's 10. So I canceled the power of 10 here. So I'm left with 1 and 2. Right, since both 10 and 20 have a factor of 10, I just canceled it. That, you see that? Okay, so then we're left with 1/3 and 1/2. 1/3 times a half is a 6. All the way to that end and then all the way to the right. It's like the opposite corner of the whole building. Any questions on number 7? What's up?
So you put this in the potentially 20 seconds.
Yeah, this is 10/10 centimeters per 20 seconds. So we gotta reduce this so we can have centimeters per second. Yeah. So whenever you have like powers of 10, you can always do that. Like, I think if you had 20,000 over 10,000, you can just cancel all the zeros. So this is really just 2. Right. That's all I did. The 6 is, so whatever's left over, you gotta multiply. So 1/3 is left and a half is left. So you multiply those together, you get a 6. So centimeters per second. And that's what that's the option, I think A or B or something.
Sometimes we just take away.
Yeah, I mean, you could have multiplied it and then reduced it later if you want. I was just trying to do a shortcut. right? You could have done 10 over 3 times 20, right? 60 centimeters per second. 10 over 60 reduces to 1/6. Same thing, right? Either way, whatever. Okay, back to the test here. So 9. Nine's straightforward. We could do that one, and then we could skip 10. I suppose. Yeah, let's do 10. 10 looks harder. You guys cool on this page? Shorten the instructions. Given tangent of theta equal to 3, find sine theta. So we should know that tangent theta is equal to opposite over adjacent, right? Which is 3 over 1. So if you build your triangle, you have, if I put theta here, then opposite is there, adjacent is here. It all depends where you put it, right? Now solve for C using the Pythagorean theorem. A squared plus B squared equals C squared. So it'll be 1 plus 3 squared. That will be 10. So C is equal to the square root of 10. So once you have the hypotenuse, sine theta is equal to opposite over hypotenuse, which is equal to 3 over root 10. Rationalize and you're done. That'll be 3 root 10 over 10. Any questions on any of those steps?
And explain, do you mind explaining it?
So they give us this information, tan equal to 3, right? So we use this to build the triangle. So remember, you can write any constant as, or any number as that number over 1. I did that only to find the adjacent piece. So 3 over 1, opposite over adjacent. You choose where to put theta. I usually put it there. Opposite is 3. Adjacent, meaning next to the angle I chose, 1. Solve for hypotenuse. Doing the Pythagorean theorem we did here. Once you have all 3 pieces, you can find any trig function. They only ask for sine though. So sine is opposite over hypotenuse. So opposite over hypotenuse. This is technically the answer, but you're going to need to rationalize to get rid of the square root on the bottom. So root 10. It's kind of, that forces the bottom to square itself, giving you a 10. 3 times root 10 is right there.
When it's opposite theta.
Yeah, opposite of wherever you put the theta. Like if I would have put the theta up here like a weirdo, then opposite would be down here. So it is your decision. Like if there's a question where they put the theta somewhere else, you need to remember opposite is now down. Okay, so it is relative to where theta is put. Any other questions on number 10? Skipping 9, 11. This basically, we want us to use a unit circle. So when you take the exam, make sure you have the unit circle printed or whatever, open somewhere. So whenever you hear exact value, but they don't want a decimal answer. No calculators. So tangent of pi over 6 means sine of pi over 6 over cosine of pi over 6, right? That's the definition of tangent, right? The ratio, I think it's like quotient rule or something in your book. The sine over cosine, pi over 6. So now you would go unit circle. What is sine of pi over 6? Which is the same as what? 30 degrees. What is sine of 30 degrees? You guys remember? I don't expect you to have the circle memorized, but I do expect you to have it handy if you don't have it memorized. That way you won't miss the easy questions, right?
Well,
I don't have the circle on me. I know it's about here. So the x value is bigger. So this will be 1/2 on the circle, square root 3 over 2 on the x value, and 1/2 on the y value. When you divide these fractions, that is the same as multiplying by the reciprocal of the one you're dividing by, right? So the 2's are gone, leaving me with 1 over root 3. Now again, you need to rationalize. Get rid of the root. That gives me root 3 over 3. Which I believe is one of their answers. Yeah, B, I guess. Any questions on 11? Hey, does Barbados have that every Monday? Like, it's not like just for a month.
No, it's like every month.
I didn't know that. It's awesome. I went that Monday. It was pretty good.
Whoa, you went?
Yeah.
No way, I had a date there. I told her I was gonna be there, or I told her about it, and then I was all over my shoulder, but I haven't seen you in person. So that's kind of weird.
It's true.
Damn, how about this?
That's funny. Hopefully it went all right, right?
But well enough to where if I'd have seen you, I wouldn't have known. So I was walking out of there.
That's funny stuff. Yeah, they've had a lot of students the past couple of years that I've never actually met. It's weird. Okay. I'm gonna throw this in the chat. Well, I don't really want to force you to write this because it's already in your review. So a radio transmission tower is 230 feet tall. How long should a guy wire be if it is to be attached 10 feet from the top and is to make an angle of 33 degrees with the ground? Okay. First of all, do you know what a guy wire is? Kind of helps, right? I need to draw something. Let's see. Guy wire. What has that? Here's a tower or an antenna. So basically, it's an anchor for the antenna. So we have an antenna, they're attaching the guy wire 10 feet from the top. And then it goes all the way down and forms an angle with the ground, 30 degrees. That's the picture they're describing in the paragraph. Do you see the picture now? What they're saying? Yeah, it forms a triangle, which is key, right? That way we can solve it. So I'm going to draw the picture now, but I need this up. So from here to here, it's 230, right? But they're attaching it 10 feet from the top. The angle that is formed from the ground is 30 degrees. So let me go back to full screen. This length, the opposite side, is actually 220, right? They're attaching it 10 feet below, not at the tip or the top. So what function should I use to solve the problem? What did they ask for, actually? I already forgot what the question was. How long should the guy wire be? So they want to know the hypotenuse, right? That's what they're asking for. I'm missing a side, but I have an angle. So we need to use one of the trig functions that has a hypotenuse as part of it. So sine, cosine works, secant works, cosecant works. Doesn't matter which one you choose, as long as it has a hypotenuse to solve for. Tangent and cotangent does not work for this one. Tangent is only opposite over adjacent. You could use that to find this distance, but they're not asking for it. They want to use I don't know, sine, I guess. Sine of 30 degrees is equal to opposite, right? Oh, is it? Yeah, you're right. Thanks. Good time. So we need to solve for hypotenuse. That's the missing piece.
Is that 30 degrees or 30?
33. All right. So multiply hypotenuse on both sides. Divide the sine out so we can isolate hypotenuse. So there we go. Hypotenuse times sine. Hypotenuse times the 220. So now I have hypotenuse times sine equal to 220. So the hypotenuse will be equal to 220 over sine 33. That's due in the calculator. I don't know what that is. But your calculator must be in degrees if you're going to do this. Yeah, it's degrees. So I got 403.94 feet. So the length of the wire is 403.93. So this check, right? For mode right here, next to the second button. And scroll down to where it says radians or degrees. Make sure degrees is highlighted. If it isn't, you're good. If it's not, just toggle and press enter.
So if I was to buy, when do I need to put it back in radian, right? So keep it in degrees.
If you're calculating with radians, you gotta switch it back. So like if you had a sine of pi over 2 or something, or anything with pi in it, yeah, put it in degrees. Yeah, let me write it bigger over here. Okay. Any question on 12? All right. That makes sense. So it looks like it's A, right? You want to do 13? Is that doable? Let's see what we got. A few stuff. Should be good. Let's do 13. Yes, cool on 12 then, right? Or no? Okay. Let me write down 13 and I'll maximize this. Tangent of theta is equal to -2/5. Find cosine of theta. So build a triangle, right? Go. So theta is equal to opposite over, sorry, tangent is equal to opposite over adjacent. So, and they also told us an information here, I forgot to write. Theta is in quadrant 2. So if theta is in quadrant 2, is x negative there or y negative? X is negative, right? Y is positive. So notice how tangent is opposite over adjacent or y over x. So where do I put the negative? On the 5 or on the 2? Here's opposite, here's adjacent. Goes on the 5. So that's what this clue tells us. This part is negative. We're in quadrant 2. Okay. So find the hypotenuse. That'll be 25 plus 4 equals C. So 29 equals C squared. So square root both sides, you'll have C. So C is equal to square root 29. But hypotenuse will always be positive. The sign only goes on the opposite or adjacent side, and that is dependent on the quadrant that we are in. Okay, so if we were in quadrant 3, they'd both be negative, right? For quadrant 4, y is negative. Remember I drew that picture with the pluses and minuses? Okay. So what's cosine? Right. Adjacent over hypotenuse. Let's take this guy over this guy. We still gotta rationalize though. And that's it. It's cosine. Any questions on any of these steps? Is it okay?
Will it be in our best interest to remember or to memorize what the like tangent, all the like secant, sine, cosecant, whatever? Like, will that be? Is there's not like a sheet we're gonna have, well, especially if you're talking units, or we're not gonna have that written down either, correct? So we'll just have to know it.
I mean, you're allowed a page front and back to put formulas and definitions. No examples, just the definitions. But there's also that whole SOHCAHTOA to help you remember. Remember that? Right,
Yeah, no, I know what it is. That's
Yeah.
right again.
okay, so using that, you can remember what the definitions are. But feel free to write stuff on your formula sheet.
Generally speaking, because like I went into like the math labs, they had a different bullet. Like, but should I just find a good one, or like there's someone you recommend, or should I just start slapping one together myself? Right? Because
I mean, I would just write down all the formulas you use during your homework, but there are a lot of trig formulas out there. Like there's one, yeah, in the lab that's decent. It's up to you.
so I was just curious.
I would just, what I would recommend is you make it yourself. That way you know what you need. Because you know what you need. That sheet might just have everything, and it might be hard to find it unless you're comfortable or you know where it is. It's your call. But that's my recommendation. Okay. Let's get 14 here. 15 is just using your unit circle. There's not much to do. I think I have my circle on me, but find one. Okay, so the question is -2 pi. So here's 0. -2 pi means I went this direction. So what is the y value if I land at -2 pi? Right? So sine of -2 pi is going to be 0. Do you see that? That's the y value. Cosine of 5 pi over 2. So here's 1 pi over 2. Here's 3 pi over 2. So 5 pi would be there. If you're wondering how do I know that, like every 90 degrees is a pi over 2. So 1, 2, 3, 4, 5 pi over 2. What is the x value? So that's cosine. So this is 0 plus 0. So all you need is a circle. And you need to understand like what direction is negative and which direction is positive. And if it goes more than 360, then just count. Or you can also convert it to degrees and use that instead if that's easier. It's up to you. Degrees is a little easier to see because that would be what? -360. So if you're just going back the same spot, just spinning in backwards. This guy would be what? Plus 360 plus, it'd be 405 degrees if you convert it. 5 pi over 2. So 405 would be right there. 360 would be a full circle, and then you go 45 more.
Explain negative 2 pi.
What's that?
The negative 2 pi.
Negative 2 pi means I'm going in the negative direction, so I'm going this way, right? So 1 pi in the negative direction and another pi. In other words, negative 360 gets me back to where I started. So then you look at the sine value, because they were asking for sine of negative 2 pi, which refers to the y. Cosine is always the x. 5 pi over 2 was here. So there's not much work to do there. It's just use your circle or memorize it or do whatever, change the degrees and then find it. It's up to you. 16, 17, 16 amplitude. Do you remember how you find the amplitude? Right. It's just the number in front. Take the absolute value of the number in front. The amplitude is 3. That's it. So if it's sine or cosine, amplitude is the number in front, but positive. Don't put negative. Like over here, amplitude would be 1 because there's no number. That's meaning that, and what does amplitude mean, right? It's how the highest it's going to go, like the space between the waves. That's all it is. Period, I gave you a formula. So let me write down these formulas one more time, starting with 16. Find the amplitude. So we said y equal to a sine of omega x, or y equal to a cosine of omega x. Amplitude is the absolute value of that a. In this case, it's the absolute value of -3. That's it. All right, 17 was period. So y equal to, find the period. So again, a sine of omega x, or y equal to a cosine of omega x, the period is equal to 2 pi divided by omega. So the period here will be 2 pi divided by 5. B. All right. So So 18, 19, 20. I just want your graph on your calculator or the Desmos app. I'm not gonna force you to do that by hand or show any work. Those are the only questions. I don't mind you just picking the right answer. Okay, so I'm hoping nobody misses those.
So if we're doing this with respondents, it'll let us open.
Yeah, I'm gonna throw a link. So right here, number one, I'll put a Desmos link. You just click it and it'll open one tab. And if we're doing in class, should it work out the same on the computers? Yeah, I mean, you can use your own. I mean, that'd be better. But if you don't have one, I don't want to force you to buy one, but you are allowed to check one out for free. Just return it at the end, or you'll get a hold on your account. Yeah, I mean, you can do either one, but yeah, talk about graphic calculator. Technically, I think they're checkout laptops too. But that's it for the review. You guys have any questions on any of the problems we did? Seem doable? Just practice them until you can do these without any notes or minimal notes, then you should be all right. Okay. I guess we'll save 6. What the hell is that? 6 for next time.